The enormous size of the cosmos is one of the scientific realities that the new James Webb Space Telescope is bringing to light. The space-based telescope has just spotted a giant object hiding in the universe. What massive object did the JWST discover? How big is it? What are the consequences of the size? Join us as we get into how the JWST just spotted a gigantic object 100 times the size of the Milky Way galaxy, among other things. Astronomy is one of the vastest fields in history. Generation upon generation, humans continue to be awed by what we see in outer space. With the introduction of instruments such as the powerful James Webb Space Telescope, there is no doubt that we will see more scientific breakthroughs in space, implying that the telescope's pretty substantial development cost of $10 billion and the intricacies of the design are entirely justified. The size of objects in space continues to astound scientists and the general public alike. The Alcyoneus galaxy, one of the biggest objects ever discovered, is proof that nature is driven to fill the immense expanse of space that exists and has capacity for life. Its accidental discovery, which is also true of many other life-changing discoveries or technologies, makes it even more intriguing. If you're wondering what a radio galaxy is, Alcyoneus is one. A radio galaxy is a galaxy with a supermassive black hole at its center. As matter falls into the black hole, it creates and releases energy in the form of two radio jets from opposing sides of the galaxy's center, also known as an active galactic nucleus. Radio galaxies are uncommon objects that form in low-density settings and have a total predicted linear length of at least 2.3 million light-years. Astronomers investigate radio galaxies to learn more about the genesis and development of radio emissions. The name Alcyoneus was borrowed from Greek mythology, and the researchers picked the name because he was the son of Ouranos, the primordial god of the sky. Alcyoneus was a behemoth who fought Heracles and other gods for control of the cosmos. A sculpture of Alcyoneus can be found at Berlin's famed Pergamon altar. The discovery of Alcyoneus, the biggest galaxy ever observed, is credited to a team led by PhD student Martin Oy. Another surprising aspect of this discovery is that it disproves several long-held theories regarding the development of radio galaxies. How is that? While the newly formed galaxy was photographed with two plasma plumes, which is unusual since scientists had never seen such large objects produced by a single galaxy, scientists understood that certain galaxies have a sphere of influence that extends far beyond their usual surroundings. What is the size of Alcyoneus galaxy? Keep in mind how measurements of things in space, such as this galaxy, works. Scientists can only capture astronomical images from a single perspective, that of the Earth, which means they can only estimate the length of a galaxy. Scientists frequently measure a low estimate of overall length, yet in the case of Alcyoneus, the low estimate is still insanely remarkable. The galaxy is more than 16 million light-years long, which is comparable to aligning 100 Milky Way galaxies. Scientists have discovered over 1,000 radio galaxies, but only 10 of them are longer than 10 million light-years. The second data, obtained by the LOFAR 2-meter sky survey, or LOT, was used to discover Alcyoneus. The LOT DR2 was reprocessed by eliminating angular compact sources and imaging at 60 and 90 resolutions. The images produced allowed them to investigate a new sensitivity domain for radio galaxy lobes, and hence constitute intriguing evidence for the hunt for unexplored radio galaxies of vast angular length. And in terms of cosmic distances, Alcyoneus is close to Earth. It is just around 3 billion light-years distant, which is still like our galaxy's backyard. Astronomers believe that the massive galaxy occupies an area in the Earth's sky similar to that of the Moon. Scientists were excited about the Alcyoneus discovery because its plumes revealed details about some of the most difficult to define filaments of the cosmic web. The cosmic web here refers to the modern grown-up universe, which appears as a network of threads and nodes known as filaments and clusters respectively. It is not challenging to observe galaxies' filaments and clusters. What is difficult is detecting the medium between galaxies, which has only been accomplished a few times. Scientists expect that Alcyoneus will alter this. This is how it works. because Alcyoneus occupies a filament and its plumes experience a headwind while travelling through the medium. This occurs with the Milky Way as well. But what is noteworthy is that this gently modifies the direction and shape of the plumes. For many years, scientists believed that the shapes and pressures in radio galaxies' plumes could be adversely affected by filament properties. However, until the discovery of Alcyoneus, scientists had never found an example of such a connection. What they now reveal is that Alcyoneus plumes are so large and rare that the surrounding medium can relatively easily mould them. So how did Alcyoneus grow to be so massive? There are some hypotheses. The researchers that found Alcyoneus believed that it was produced by a gigantic black hole. A vast number of stars with a lot of stardust were extremely powerful jet streams, but they determined that Alcyoneus does not stand out in the three features listed above. The fact is that the origin of Alcyoneus remains a mystery for the time being. Many people are aware that planets have moons. The Earth, for example, has one, as any high school geography student can attest to. Some planets, like as Jupiter and Neptune, have numerous moons. What is less frequent, however, are asteroids with moons. Only approximately 150 of the roughly 1.1 million asteroids found so far have moon partners. But astronomers have discovered an extremely rarer asteroid with 3 moons. How did Electra, an asteroid, acquire not 1, not 2, but 3 moons? It's noteworthy to highlight that while Electra was initially seen as an asteroid in the 19th century, its position as the supreme commander of an army of 3 moons was only recently verified. In 1873, a 160-mile-long asteroid was discovered in the belt of asteroids that lies between Mars and Jupiter. Its first moon was discovered centuries later in 2003, and its second moon was discovered in 2014. 130 Electra, or Electra for short, also demonstrated to scientists how to locate additional weak, difficult-to-find moons, such as those connected to asteroids. Asteroids are rather small and only weakly lighted at best, thus anything even smaller placed next to an asteroid will be dimmer and fainter, since it will most likely be significantly outshone by its parent asteroid, which means moons smaller or closer to their parent will be difficult to spot. Exoplanets are extremely elusive as they circle their anchor stars for similar reasons. The first moon circles Electra at a distance of around 1,300 kilometers on average and is 6 kilometers long. The second moon, which measures barely 2 kilometers wide and orbits the asteroid on average at a distance of 500 kilometers, is even smaller, with an orbital distance of about 340 kilometers. The newest moon is also the smallest of the group, measuring only 1.6 kilometers in length. This makes it challenging to see. Compared to the asteroid, it is around 15,000 times fainter. Anthony Burdu of the National Astronomical Research Institute of Thailand and his colleagues made the discovery of the third moon orbiting Electra. The team of researchers laboriously processed the data through a recently built data reduction pipeline to meticulously and effectively reduce noise from the raw data from the SPHERE instrument mounted to the European Southern Observatory's Very Large Telescope. The SPHERE captures extremely detailed imagery of objects in space, and with the aid of a 10-meter telescope, it can extract images of extremely dim objects. The third moon, curiously, was detected in older images using modern processing techniques. They employ data processing methods to predict and erase the asteroid's wide light, known as a halo. Electra's third moon appeared after the data had been processed, hence the moon was in the data the whole time, but was invisible to the processing procedures available in 2005. Scientists are still working to understand several aspects of Electra and her moons. For instance, they are unaware of how 4 objects came to be associated. One idea is how the 2-moon asteroid Cleopatra originated. Though scientists haven't yet established how frequently the process occurred in the solar system, they were able to conclude that the twin moons likely originated from material expelled by the parent body. All 3 moons might have originated in the same way as the Earth's moon did, which implies that they were most likely generated by the impact of another asteroid hitting onto Electra. One reason scientists look for moons orbiting asteroids is to increase the accuracy of mass calculations. if an asteroid lacks a moon, its mass can be approximated using its size and composition, although the procedure may provide inaccurate results. However, when moons are present, astronomers are able to determine an asteroid's mass using a set of Kepler's equations. Scientists can extrapolate the density of an asteroid from its mass and size, which provides a wealth of information about its composition. It can determine if an asteroid contains metals or is simply a mass of low-density rocks bound together by gravity. Therefore, a great deal of information about an asteroid may be acquired only by learning about its moons. The finding of Electra's third moon also serves as a kind of trial run for a method that might revolutionize how we find astronomical objects. It's important to keep in mind that the moon was discovered by looking at existing data in a new way. As a result, many moons may still be hidden in old data, ready to be discovered. All it takes is a fresh look at the data. Let us know what you think about these incredible space discoveries in the comments section below. If you enjoyed the video, take a moment to subscribe to the channel.